Hello, everyone. Welcome back to SAT Math Question of the Day. Here's our question of the day. Please try it, pause the video, come back, and we'll do it. Okay, it looks like we have to deal with the exponent rules, don't we? Oh, wow. But looks interesting. This is the exponent rule in reverse. We're going to use... Oh, I have to put annotation on. This is x to the a times x to the b is x to the a. Mm-hmm. No.
No. No.
No, it's not. No. This is x to the a to the bth power is x to the a times b. So this is 16x to the half power, or it's 16 to the half power raised to the x power, raised to the x power. Right?
Yeah.
So that would be 16.
And this is the 16th. The square root of 16 is 4.
Right, yeah.
And so it's this.
Yeah. Sorry. Well, man, I realized this.
One of the things in the SAT.
Oops, sorry.
You have to know, for all our audience, the distinction between adding and multiplying.
Well, obviously.
Yes.
I think
so. Keep in your mind: is it adding or multiplying? And don't just it's the exponent rule. No, it's adding, multiplying relative to exponents. And here, this is a multiply.
I know. I would have caught myself.
No. I'm just saying this because we're approaching SAT questions. Of course you know it. Yeah, you know it. Sure. But for our audience, the key idea is what's the key idea? There are exponent rules, exponentiation rules.
Yep.
And it's a good idea to just memorize memorize the rules, memorize in terms of the formulas and what they mean.
That's right.
So this is the exponent rule for multiplication. The other exponent rule.
What do you mean for multiplication? No, for raising something to another power.
Yeah, it's the exponent rule where the exponent is a product.
But you didn't make that clear.
It's where the exponent is for and then this is the exponent rule where the exponent is a sum. So here the exponent is a sum, and we have the interpretation is the product of the of the exponentials of the two addends of the sum. And then when the exponent is a product, the simplification or the equivalent form is exponentiation.
Right. But it depends.
So we could call so I think it leads us to a way of thinking that it's not a good idea. It's not a good idea to give the name multiplication or addition rule to these things.
Of course not.
It's not a good idea to think of one of these as addition, for addition, others for multiplication.
Of course not.
They are rules that are expressed by these formulas.
Right.
Yeah.
No, that's why when you said the word multiplication, no. Because you could also view this as multiplication. This is the multiplication of two numbers with a common exponent. So that's the one can think of
a common base.
Right, common base. Yeah. In fact, this is usually known as the product rule. Usually.
Yeah.
And usually this is known as the power rule.
Usually is what teachers say, right?
Right, yeah. Usually this is known as the product rule, and then the other one is known as the power rule. But the more important thing is to just know the rules, and as really important, when they apply. And I started going down the wrong path. I had a rule that was right, but it didn't apply to this problem. But
let's see. F is AB. Yeah, yeah.
I just want to quickly show that what this would be 16 to the 1/2 plus x. That's 16 to the half times 16 to the x. Right.
Which is 4 times 16 to
4
the x.
times 16. Look at that. It doesn't even have that as a choice.
Yeah.
Wow, look at that. Wow. So if I was doing that rule incorrectly, I would have had a problem. But this is a little interesting. You don't normally see this rule applied going backwards. Normally you see this
no, it's normally. It's mathematicians need to know it both ways.
Absolutely.
There's no normal.
I totally agree.
And in the SAT, it's fair game to go either way.
Okay, so let me change it, Seth. Less familiar. Okay?
To you, maybe.
Okay, fine. It's a less familiar application of this rule. Okay?
To you, to Joel.
Yes, to me. Yes, it is a less familiar application to me. Okay, fine. Okay. But here, everything aside, the main idea of this problem that the people who wrote this question, they want to make sure you understand the exponent rules and how to apply them.
Yeah. Shall we talk about why these two exponent rules are true? At least in the case when the exponents are natural numbers.
Well, let's just mention one more exponent, and why don't we just do the power rule? Okay. Why don't we mention one more exponent rule, and then why don't you do it for the power rule? Okay. But not for the. Okay, but anyway, x to the b divided by x to the a is x to the b minus a. So if you divide two numbers with a common base, you subtract their exponents. If you multiply two numbers with a common base, you add their exponents. Sure, yeah, you want to talk a little bit about how the power rule works?
Yeah, well, the power rule, in the case of natural numbers, is a consequence of the product rule.
That's right, it is. So you want to show that?
All right.
Power rule.
So in the case of integers, yeah, x, what are you scribbling about?
I'm writing power rule. I'm writing it. X to the a to the bth power is x to the a times b. And I'm done scribbling.
Okay, so x, and when a and b are counting numbers,
okay,
x to the a raised to the bth power, it means x to the a multiplied by x to the a b times. Right?
Absolutely.
And then using the product rule, b minus 1 times, we get x to the 2a. X to the a times x to the a equals x to the a plus a, which equals x to the 2a. It's x to the a, bunch of x to the a's. And we've picked off b minus 2 products here, and you just multiply them out. So we have b x to the a's multiplied together. So there are x is multiplied by itself a times, and then again another b times.
Right.
So we have x times x times x multiplied out a times b.
Right. Yeah.
And that equals x to the, where the exponent is a times b.
Right. Right. So then, right, that's why if you ever have a problem like x cubed to the let's say to the squared power, you without even knowing the exponent rules, you can just write it out of what it is. It's x cubed times x cubed. And then you bring in the product rule, which is x to the sixth. So you see that.
That's because 3 plus 3 equals 6.
But when you have something raised to an x power, you can't do that. That's why you need the exponent rules, just in case you get raised to a variable. So without
so with the idea of the exponentiation is the concept of multiplying the base by itself a certain number of times, and that number of times is called the exponent. And then mathematicians have extended this to where the exponent is not a counting number. Right. It's a number. It could a number that's not a positive integer. So first they extended it to 0, and they made base raised to the 0th power equals 1, so that the product rule works.
Right.
And then they extended it to when the exponent is a negative integer, so that the product rule works when a and b are negatives of each other, like a equals 3 and b equals -3.
Right.
And then they extended it so that the what's the other rule? The
a and b can be fractions.
To where a and b are fractions.
Right.
And then to make it to so that x to the reciprocal 1 over a, where a is an integer, is a root, an eighth root.
Right.
And that's done so that where am I? So that x to the 1 over a, if you raise it to the 8th power, you get x to the 1 over a times a. The 1 over a times a equals 1, which is x to the 1. And since it's 1 it's just 1x, is x. And so x to the a is defined to be that number, which when you raise it to the 8th power, you get x. And that is the 8th root.
Right.
That's also known as the 8th root of x.
So in other words, you're saying that the way they figured out that x to the 1 over a, which is, by the way, an exponent rule, which is the 8th root of x, they came up with that rule because they wanted to, it's a consequence of forcing the power rule to work.
Yeah. So rather, the meaning of exponentiation for non-integer exponents was defined so that these two rules work.
I was going to ask you to explain that in 2 minutes or less, and you even did it without the request. So that leads to the all-powerful x to the a divided by b rule, which is the bth root of x to the a, or the bth root of x raised to the 8th power. Usually this one is the one that's used more because you want to make the number small, right? You want to take the bth root of the thing before raising it to a power, as opposed to raising it to a power and then taking the bth root of the thing. So this is the one that's more used in practice when you're solving something. But yeah. So thanks for explaining that. I was going to ask you where that came from, and so they fudged it basically. They came up with this so that the power rule and the product rule work. Wow, pretty cool. Yeah, and then the negative sign, right? And then x. Now we're really done. Now we're going through all the exponent rules.
And then there's a different approach. Different. I think rules of mathematics are not developed in only one way.
Makes sense.
There's another approach to defining exponentiation, and that is to start with the definition of what's called the exponential function. And that is the exponential function is denoted by e to the x.
Right. So that is,
and then they use that the approach there is calculus.
Right.
They use calculus.
That's right. So that
to define the function that turns out to be e to the x.
I've read that in books, and frankly, I need to spend more time following it. I'm sure I can, but I really need to follow it.
You cannot be sure that you can until you actually try following it.
I've looked at it and said I could follow this if I have the time.
Well, one should not believe someone who says I can follow it if I looked at it.
I agree. But guess what? You're my brother, and if I do have the time to really understand that, I can. Thankfully, I'm blessed with a brother who has a PhD in math from MIT, who's been a teacher of computer science at University of Albany for a lot of years. He's now retired. I could call you up and say, Seth, I'm sort of following this. Can you explain it to me? But I think it's sort of interesting about this e to the x thing. Definitely interesting. Yeah. I mean, e to the x, and we'll talk about one thing about it. When you do e to the x, you have to say e to the x is an amazing function because when you say something changes if you want to look at the rate that something changes, the e to the x function is the function where the rate at which it changes equals itself. It's crazy. It's crazy function. If you look at a thing here and you want to see what is the slope of this line, the slope of this line equals the value of where you are, where the value of the function. So like over here, let's say it's 1. If the value of the function is 1, your slope is 1. If the value of the function is 20, then your slope is 20. Crazy function. The rate of change, the slope of this function, wherever it is equal to the function itself. It's crazy. It's called the exponential function. It explains basically COVID in March of 2020 when things rose exponentially. Amazing function. It is the quintessential function in calculus. Yeah. Okay. Are we done?
Yeah.
Boy, we are done. Okay, so I'm Joel. I have a PhD in mechanical engineering from Columbia. I take more practical approaches, get the problem done. Seth explains things theoretically, thank God. And he's so we have different approaches, we have different thoughts, but we try to get together and offer how to do these questions. But we always try to ask the 3 main questions. What is the main idea of this question, which we did? Does a calculator help? This is from the old style October 23 test where this was not a calculator question. That's obsolete. Every SAT question going forward now is going to be a calculator because it's digital SAT. And what's the other thing we ask? Oh, would you do this question any differently in school than you would do on the SAT? In other words, would you guess and check? Probably not. You would just do this. You would just sort of look at this, apply the exponent rules, and get the answer. So that's about it, right?
Yeah.
Yeah. So please give us comments on our videos. Like or dislike us. Comments are encouraged so that we get some feedback. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Okay, everyone. Today's a Friday for us, at least today. And I'm not sure when you're watching the video, but whatever. Today's Friday for us. So have a good weekend if you're watching it live, when we recorded it. And we'll hope to see you next week when we continue marching through the SAT questions. Take care, everyone.
Hey, goodbye.